Good morning, everyone.
Hey, good morning.
How are you guys?
Excellent.
Oh, thank you. And most of you guys have a data background or anybody from the app side here today? Yeah. Okay. Okay. So I'm going to talk about the deployment of applications globally. Basically, wanted to talk about how we can scale apps, how we can do high availability for apps, and so when we talk about lab or a development environment, it's just a small environment. And once you take it to production, the size and the scale of that is totally different. Some years back, this was the job of the IT operations team. And nowadays, the boundaries between operations and development has shrunk, especially with the advent of DevOps and processes like Agile and all that. We are actually talking about infrastructure as code. So a lot of the things that we used to traditionally hand over to other team for management has changed, and then there are some nuances that we need to be aware of when we are developing code. Right? There are situations where we wanted to design for availability, and there are some design patterns that we want to use for making sure that it can work with multiple instances of the application in place. So those are the things that I'll cover today, and we would walk you through from a single small-scale application that is in a very rudimentary format, and we'll take it up to a bigger scale how we can. So my name is Kumar. I'm a cloud solution architect with Microsoft. So my job is to help my customers to transform their applications, to modernize their applications, and bring their apps to cloud and help with all those processes. So with that, let me just go on here. So just before I go into the meat of the stuff, I will talk a little bit about why we talk about cloud and all these transformation stuff. So technology is omnipresent and it is changing the way we do things, and companies are responding to this by doing several things. They engage customers more and transform products. The expectations from the customer is ever increasing. We cannot have systems that are running like in the scale and format that we used to have 10 or 15 years back. People are expecting high availability, 24/7 coverage, all kinds of things like that. So, and companies are empowering employees to use more modern tools to do experimentation with that. So there is the cloud philosophy is coming into picture there. So they would allow you to make sure, help you to use these tools and build stuff pretty quickly and easily. So, and optimization of operations, all that stuff. So we'll just move on here. And this is also an interesting Gartner study that says that around 1 million new devices are coming every hour by 2020. And there is a lot of things happening in the mobile world, right? The application is moving, basically if you are a bank or anything like that, if you are not supporting your mobile applications, then you are pretty much out of business nowadays, right? It's almost like, the web development and the mobile development are equally important. So we have new devices coming online, and especially the new generation are very much doing their transactions in the mobile space. And the average lifespan of companies is also shrinking. This is because of the ever-changing technologies that are coming up, and the struggle to be there is always is much higher nowadays. And again, we're all going to cloud. 60% is supposed to be cloud, which also means that there will be some sort of computing that will still happen within on-prem. That's the design philosophy of Microsoft. We actually always believe in hybrid cloud. So most of our tools we are actually catering towards a multi-cloud, hybrid cloud infrastructure. Same tools we can bring to cloud as well as to the on-prem environment. So that's kind of the thing that we always care about. Now, I think you all know these things. I just wanted to bring you into the conversation so how these things evolved. In the beginning, we always had mainframes, and all we were doing is like a terminal and the jobs were running in the mainframes, and the terminal was a dumb terminal. It actually displays what is happening in the mainframes. Then we actually moved towards a little bit more of distributed computing, where you actually type multiple mainframes and then move the critical jobs from one place to the other, adding all these things. And then later on, we came up with the client-server model, basically involved the fat client, which means that your terminals are not dumb anymore. You do a lot of processing on the terminal on the customer side itself, which is also a nightmare. You have to deploy the app on the customer side, keep it up, and you cannot scale that. If you have thousands and thousands of users, you're going to have them updating their application. So then basically we just, that was more like a consolidation effort into single VC large servers. Then we actually still went towards distributed computing. And with message-oriented architecture and more enterprise layering and all sorts of things happen. And again, we have high-density forms, and then the computation moved towards internet. And your fat client is becoming a browser now. So basically, the browser is doing all the customer-facing stuff, and then you will have your application running in a form-based environment, like a lot of stuff. Right? Those things happen, and virtualization came up, and eventually we have cloud. So cloud is basically you have you're moving away from your on-prem, and then somebody else is hosting your data center for you. It's almost like producing your electricity versus buying your electricity from the grid. So it's almost a similar concept here. Now let's move on to some of the essential aspects of the cloud. Probably you guys know all these things, but I just wanted to refresh my memory here. So when we talk about the essential characteristics of cloud, we are talking about on-demand self-service. So the cloud has to be is a service that is self-managed. Like people are subscribing to cloud and they actually orchestrate and spin off their environment in the cloud. And for that, easy provisioning, faster provisioning is required. There is no need to call somebody and ask them to do all these things for you. And gone are those days when we actually wait for 10 or 3 months for the server to be available and work with the team and to provision it and all sorts of things. And then the second part of it is the network access, right? The cloud is accessible across the world to a variety of users, a variety of devices, all sorts of combinations. So it is just not a single platform that your company only uses. It is going to be used by several customers. So you should have a way to have the network access available. And so we have a highly scalable software-defined networking as part of the cloud. And then the resource pooling, it's almost like a multi-tenant environment. So it's a multi-tenant environment where you have common services. You can actually have several users using the same thing. So you're living in an apartment, so you have boundaries across your place. And you need to have all the security aspects and the pooling effect. It's the economics of scale, pretty much. And you are sharing stuff, and then you are getting money out of it, right? So because you are just using part of the infrastructure. And then measured services. You are moving from capital expenses to operating expenses. So you need to make sure that you are measuring how much people are using and charging accurately. That's also an aspect of cloud. This is how a data center differs from cloud, right? Data center, you have everything that you just use it. You don't care about all these kind of things. I mean, there are some of those, but that's not in the scale as well. And then the elasticity, you'll be able to scale up and down as soon as you want. Now, I think you also know this part. It's about the differentiation between the different models in cloud. So when you are running on-prem, you package everything, you run everything, you own everything, and you are responsible for making sure that all these things are maintained. And it's a lot of work and heavy lifting in there. But in the infrastructure services, you own the server, and then everything above that you own. Basically, maintaining the patches on the operating system, maintaining any malware protection, and all sorts of things. It's almost like you are renting a server and you're building on top of it. So everything below that, providing that server is the job of the cloud provider, but everything else is yours. from that you can actually optimize your operations or your environment by moving towards a PaaS service. In a PaaS service, you get a platform. You don't manage servers, but you only get services that you get. And then you only manage the applications and the data that you put on those platforms. So basically, a lot of the work, non-business specific work, non-application specific work is moved away from you. And when you are in a software as a service, you don't care about all these things, you just only care about your account. You just have an account and you provision your account to use them, like, for example, like a Microsoft Office 365. So, and I also want to talk about the big picture on network, how the network works in a cloud environment. So there are multiple elements to this. You will have an on-premises environment, and you will have your customers. The customers come from the internet. The on-prem environment gets connected to your Azure cloud. So basically, you have a local area network in your environment, and by virtue of moving towards cloud, you are extending your local area environment. So you have a set of servers with a set of local IP addresses. You wanted to have that and move towards like kind of carve out the space in the cloud and then extend that to the cloud as well. So basically, that is called the virtual network. Virtual network is a logical boundary for your data center or like for your cloud space, where it almost feels like these servers sitting in the virtual network are in the vicinity of your own environment. These environment basically you connect them to technologies like Express Route, which is a dedicated line. Or you could do a VPN tunnel. VPN uses a traffic over internet, but it is a tunnel. There is not like a physical tunnel, but it is a logical tunnel created because of encryption. Like nobody else sees that traffic, so it is almost like you are going through a tunnel. And with that tunnel, the branch office or whatever office you can connect to internet into Azure. And your local machines are sitting here, and then this goes, and then everything else get added to your network. So that's how you. This is primarily important for your IaaS servers. Basically, your server extends, your server space extends to the cloud. But for PaaS services, it's more shared, so they will be in a different space. But there are technologies that you can use to tie those PaaS services into your virtual network by using something called service endpoints and all that. But obviously, PaaS services are more for it's again a shared service, but you can have dedicated instances depending on the tier of service that you buy. So that's how you save money in PaaS services. Yes. So Express Route is a dedicated line from your on-prem to Azure. You have providers. There are a couple of different ways you can do Express Route. So you have, let's say you use some service providers for that. So you wire up to the service provider in a co-location facility, and then Microsoft has a presence in that facility. And this is a dedicated line to that facility, and Microsoft has a dedicated line, and you actually interconnect in that co-location. And interconnection is a logical connection. You just make sure that these kind of packets coming from these stores is routed into Microsoft. And you can do that way, or there is other ways, like if you have an MPLS WAN where you have a provider that connects all your branch offices and all that. If the MPLS provider has a connectivity to Azure, you don't do anything. You just tell that these kind of packet headers are going towards Azure, and the routing takes care of that. So basically, it is a dedicated line, just like you lay out your connectivity between your environments, right? But in the normal VPN mode, you don't have a line that is run, but it is just sent out to the internet with the encryption, right? And then it goes all the way to Azure.
This is Express Route encrypted as well?
Yes.
Do you have any roadmap for the service endpoints that can be with all the Azure PaaS companies? Like what are these already available?
Yeah,
what is coming in the future?
I don't think they will publish that. It may be some of them internally, but I know that it is available for SQL.
Storage and SQL are having. Any other stores? streaming have it?
There is a link. If you search for service endpoint, you will see currently available services.
I don't see the things that is coming in.
Yeah, that is normally not published. And we don't even know that. We have to go and ask them that. They will say some of them are NDA, they will share it, but then they won't. It's actually there for the streaming, right? So, and again, some of them are driven by prioritization, by customer ask.
What is the service endpoint?
Service endpoint is it's a PaaS service is a shared service, right? So let's say you are creating an app service. So you can host your app on that, but the app service is not running in a VNet. It's not running in your local area network. Okay. It's running in a Microsoft network, and you put your app in that, and it has a public endpoint, and people connect to that app.
Right.
And some people don't like it, and even though it may have a public endpoint for the customers, but they don't want to have the management of all that through public endpoints.
Right.
So they will sometimes even if it's like, let's say if you need a public endpoint. So you you cancel out all the public facing part of the app and force it to move to have it connected to your VNet. Okay. Basically, it cannot be deployed on the VNet because VNet is like a logical construct. It is always deployed on the Microsoft network, but then it seems as if it is part of the VNet. Like you can force it to work with the VNet.
Based on the network rules.
Yeah,
It's probably more secure than anybody cannot reach other than your own.
Yeah, nobody else can route into that outside that VNet.
Okay. Yeah. So it's essentially like having your own network.
Correct. It is obviously because the virtual network is coming and going. Like it's a volatile concept. Like you just create a virtual network and nobody else creates one. So you cannot put all your PaaS services everywhere like that, right? It has to be in its own space.
Yeah.
And but then you will tie them together.
Okay.
So this is actually the primitive form of an app, which is a lab environment or a development environment. So what we are doing here is that you are lifting and shifting a small app into the cloud. So you have in this scenario you have a virtual machine and a bunch of storage accounts, and we have some disks attached with the virtual machine. And some of the considerations here is how much is the size of the virtual machine, whether it is storage optimized, compute optimized, or things like that, and what type of data you want. You want premium storage, SSDs, or hard disks, standard hard disks, or things what is the scale you need. And then you also may use storage devices for like storage accounts for any shared drives that you may have. So this is a very easy concept. Like this could be used for a web application or any computer-oriented application. Like let's say you have a video processing or things like that. You can easily do this, but you still own these servers. And you run these servers, but you will own the management of all these servers. It's not a PaaS solution. It's an IaaS solution running a single VM. Now let's go into the next level. How do we make it a little more resilient? Let's say in the single server mode, if the server goes down for any reason, then you don't have a place to stand. You don't have your app is out. So we just make it a little bit more available by adding another server. So we actually add an external load balancer here. The load balancer is actually balancing the load between these two servers. And we will talk about availability sets in the next slide. So that's a protection that you need to take care when you are putting multiple servers. You want to isolate where they are located. Like you don't want to have a bunch of servers sitting in the same place and one of them goes down because of the rigidity of all the the infrastructure. You don't want the other one to go down as well. You want it to separate out as much as possible away. So that if this is down, then your load balancer will still go to the other one. So that's the concept. So the NSG is actually another concept. Like when you are like trying to balance the from a load balancer into multiple servers. NSG is a network security group. It's actually a 5 tuple. It gives you, it's just a table where you have several inputs and an output, whether allow or deny is the output. Inputs are like your source IP address, your port, destination IP and destination port, and then the protocol that you are using. So you just say that this protocol, this source destination is allowed, this is not allowed. So that's kind of the rule. Then it's just like a table for validating the graph. So this is how you can actually make it a little bit better by making it running into two places at the same time. Now let's look at what is the availability zone and an availability set. So when you look at a region in Microsoft Azure region, you will have multiple data centers in the region. So each data center we call it availability zone, and by virtue of being in separate buildings, you are having the physical infrastructure is different. Like you will not have different power supplies, different switches, different racks. All of them are different, and these are all separated by some airspace. So if you have a server here and a server here, if this whole building goes down, the second server will survive, and that's the concept of that. And now, not all regions may have availability zones, because it is we should have multiple buildings and infrastructure. Some of them may not have, and even whether you have availability zones or not, the concept within the data center is called availability set. So I am expanding this part. This is a Azure data center, and if you go to the Azure data center here, you can actually isolate based on availability sets. So the availability set uses two concepts. One is called we have two things in the availability set called fault domain and an update domain. A fault domain means that it is isolated by racks and power supplies and switches within the building. And if two servers are in two different availability sets, they will not share any power supplies or switches or all that. So if this rack goes down, it will survive that. And the update domain means that there is a schedule of updates. Like if you are having a server in Azure, we at Microsoft come and update and do patches into the server, right? So by being in two different update domains, we will not pick up those two at the same time for updates. So this one actually prevents from unplanned outages, like a rack goes down. This prevents outage usage during planned outages, right? So if you have like 4 servers, you can actually put 2 of them here, 2 of them here. The 2 here can be in 2 different availability sets. That way you have maximum isolation. Yes.
So I'm actually more familiar with like adding functions.
Okay.
But in the Azure function world, can we do that? Like, we have to do that.
No, that's internal to Azure. So it will Azure will take care of all that stuff for you. That's the beauty of having a PaaS. Right.
Okay. The reason I ask that is I've noticed at times that a function will start, not behaving. And my guess is that it's because they're deploying like new software.
So there are 2 different ways of doing functions. One is a consumption model and app service model.
Consumption.
Yeah, if it is a consumption model, it's a very transient model. It has to bring up the app. All this, function is basically a machine running at the back end and then hosting that environment for you. But when you are using consumption model, it is pay for use, and so it has to bring up the whole environment every time you start this function, right? So depending on the load and noisy neighbors and all kinds of things, it could be not very predictable, right? But if you create a function within app service model, it is dedicated and set for you, but you will have to pay for the entire instance. And it kind of defeats the purpose of functions, which is more like, but still, we are talking about performance there.
Okay. So is there any way with the consumption to sort of guarantee that your functions are deployed in separate availability sets or anything like that?
The functions per se is only one server, and so it's a point in time question, right?
Okay.
There is no redundancy there usually, and the Microsoft backbone should take care of all that.
Okay. Thank you.
If you deploy the availability zone, technically can your updates get done at the same time on those 3 different? So if you deploy it in an availability zone, deploy a server or whatever in an availability zone, so So we've got 3 instances of it. Is it like the availability set that it won't actually update all 3 servers at the same time?
No, if you won't put you are not deciding where to put these things, right?
Right.
You just go and select I need an availability set.
Right.
And then it will distribute it in different sets.
Yeah, for sets I understand, right? Because I understand that you've got full domains and update domains, right? What I'm asking is if you deploy only in an availability zone without a availability set,
Okay.
will you get the same update domains and full domains?
I check on that. I don't know. I think if you go by availability zone, Microsoft internally will take care of.
No, they would never update 2 zones at the same time.
It's if you are already at the availability zone level, it should take care of that.
Yeah, because the SLA is meant to be like the highest SLA you can get.
Right.
So you would hope they're not.
Yeah, I hope they are not that down.
Okay. Thank you.
One question. Yes, we got all services part of Microsoft backbone and services outside the company. Like Azure part of the backbone.
What do you mean?
All these services is part of the Microsoft backbone.
Yes. What is backbone? I don't.
This request coming from the Microsoft is one location of one backbone at the layer.
So if you say backbone as the networking infrastructure, if you think about that, we have internal connectivity from one region to the other and across the world. So Microsoft has, I think, it's one of the biggest fiber consumer. Like we have fiber laid out all over place. But all these services are deployed within Microsoft data center. We are not putting it in anywhere else. Right?
So my question is about sometimes you have the hybrid version of apps. It's not the passive app, but the component sits on IaaS of the organization. But maintained by Microsoft, but owned by the organization.
Yeah, there are some scenarios.
But the request comes from backbone.
Yes,
there are some services like the Azure Batch doesn't come from the Azure backbone. It is public endpoints everywhere.
I'm not sure about that. Yeah, but there are some partnerships where they put stuff. For example, VMware Cloud Symbol is a place where we have places that we put stuff with the partnership. But most of our services are in Azure, right? And that's what I heard. But maybe I'm wrong. Yes, I'm sorry, I'm just. So now we are actually going one step further. Basically, in the previous blueprint, we just had servers and media databases, but everything is a monolithic application. We have the app running in a single server. Now we are actually making the different layers and tiers. So in a very modern application, we don't want to run everything in a single server. We are actually delegating responsibilities into different tiers. So we will have a web tier. So basically, this is the classic MVC paradigm. If you remember those model view controller. You have a model, which is your data and everything, and a view. You are looking at the app from a view, which is a presentation layer, and then you have a controller, which is actually doing all the business logic, right? So changes in the controller should not affect your view, and the view changes should be contained within the view, and the model changes. If there are model changes like your tables change and all that, your controller should be aware of that, and it should take care of that. So we are actually we're making sure that. Just an example of a car, if you say your car you are changing a tire and if you have to change your engine, then that's kind of a bad design. Right? So we don't want that. Right? So same thing here. So basically in this scenario, what I'm doing is you have a load balancer that actually takes the traffic across multiple instances of the virtual machine in your web tier. And in the web tier, it is going to talk to the business tier, but you are not tightly coupling any machines to any machine. You are actually using a balancer here. so that you're only talking to the load balancer, which will find an available server within that column. That's what it is doing. And then the same thing for database. Database usually you cannot have multi-master databases. So that's kind of this arrow here, but it could be a replica of the database. But mostly you will be switching over from this database to this one if the other one goes off or something.
So this is great for having, having a couple. But how's performance effective? Is there any performance?
So I will talk about scalability and performance in the next couple of slides. This is the basic stuff, right? I'm actually, from a monolithic application, I'm going to provide a more, compartmentalized type of design. So now, let's talk about how we do resilient applications architecture. So we just talked about a couple of these things already. And if you are in a single virtual machine, any hardware failure, you are pretty much lost, right? You don't have anything. So in the availability sets, if your rack or something fails, you still have another place to. And again, when you go to PaaS services, a lot of these things are transparent. You don't really care about it. You are using a service which Microsoft is responsible to provide the SLA for all that. So when the rack fails, you go into the other rack. In the availability zone, you are actually protected against a data center outage. Basically, you just have multiple data centers connected to them. And then now we are talking about a natural disaster, which is basically you are thinking that your whole region goes down. Maybe there is some natural calamity or whatever. So in that scenario, you have a replication scenario where you have all your data replicated to another region, and then you could make it more like an active type mode where the traffic goes to both places at the same time, and if this data center or the region is out, you can actually go to the other region, or you can make it active passive with the manual failover and all. So this is the evolution of the application from a single server to a multi-region application. Right? So, and again, this actually gives you high availability and DR, but then there is another thing called backup, which is for data corruption. This is similar to your old school data backups. When the data is corrupt, you will have to go back to your old data and then bring it. Whether you have this or not, backups are important because your app may fail up sometime due to whatever reason it is. Everything infrastructure is there, but the app data is bad, and so you will have something to take and bring back the app from an old backups.
One question here. Zones you have the data center outage generally when Eastern region ECUs to down for an hour, why would it take so much of time? Because if you have any zones of backup, then you can reload the traffic. It generally takes about an hour and 2 hours when zone completely down. Especially most of that happens in ECUs.
Yes, I mean
it's down. It takes about 1
zone
hour
or set.
It's complete zone.
Yeah, zone outages may be difficult because it's the whole building is gone, right? Finding out the real root cause of that could be anything.
But while you're doing it, application can read out to the different backup zone, whatever you are internally maintaining it. You don't have to feel like a customer has.
Yeah, so that is, if you're using an IaaS service, it's part of that is
PaaS offering.
PaaS offering. These things are very complex sometimes. Sometimes we don't. It's a case-to-case basis, right? If it is something that is easily switchable, then obviously we'll do it. But PaaS services, Microsoft owns the responsibility to make sure as fast as we get back to the other region.
Yeah, I can understand the zone can be power outage, the power card, it has to come back. But my 9999 49 has to read out to somewhere else, and my application should come up again within a second.
Yeah, so the configuration of that is actually important, right? So if you are having a manual failover, then I don't know what part of PaaS service you're talking about, but if let's say you're talking about an app service, right? If you have app services in 2 regions or in 2 zones or whatever, then if your application is not designed to automatically go into the other place, then you will have to do some sort of manual configuration to route the traffic in the net. So that is actually a delay here, right? So that's what I will talk about a little bit of those things as well, right? Automation and failover automation. Now let's talk about how a PaaS-based application deployment looks like. So we just talked about IaaS mode. I think I'll have to rush quick. So in the PaaS model, basically we don't use any servers. We are actually moving everything to a PaaS model. Instead of having servers, we are deploying an app service. And instead of the database, we are using Azure Database, and this is a logical server. There is no physical server, but you get a logical database server, and your database instance is on that. And you will have an internet-facing endpoint for your app, and you can post that in an Azure DNS or a DNS of your own choice. So this is how you will build that in a PaaS model. Now let's moving. How do we improve scalability of the PaaS model, right? So in the previous environment, you are talking about, if you look at the differentiation in the PaaS, in the IaaS model, where you had a single monolithic application and a business tier app. You could actually have multiple app service tiers, but then I'm not putting that in this picture now. So this way, I am actually trying to make sure that the round trip time for my app is as good as possible, right? I wanted to do a transaction for the user, and I don't want to be tied by some of those services that are actually in the backend. So I wanted to schedule some of those and push it out from the app, and then get back to the customer as soon as possible. So I will have the thin layer of the app here, and I can even split it into app web and all that stuff here. But it's just I'm doing it into pieces. But anyway, we will use some load leveling type concepts, which will make sure that you are separating some of those synchronous versus asynchronous processes in the app, right? You just I have a request, I have to serve the customer as soon as possible, but then let's say the user is putting a own application or whatever, and then I'm just putting it into a queue for somebody else to come and pick it up, but I'm not waiting for something to happen and all that. So this is a remote call or whatever it is. Instead of that, you can use several technologies. Right? And then the Redis cache is another way you can do performance. You can have a SQL server at the backend or Cosmos DB, but instead of reading directly from the database all the time, you can actually use a Redis cache and again, the other things are like CDN. CDN is actually a content delivery network. If you have an application that is globally distributed, every time when the user comes in and for any static assets like images or some of those text which are static, it doesn't have to go all the way to the app. You can actually deploy these things in the CDN, which are like endpoint edge processing, right? So I am here in DC. Let's say the server is in West US, like somewhere in California or whatever. So I wanted to have my page loaded as fast as possible. So my static assets are sitting in the edges in all this. That is a CDN part. And it may use a blog to get those pages and all that. So this is I have rushed through.
Is there a reason that we don't use traffic managers?
Yeah, I have it. Oh, yeah. Yeah. Okay, so this is another way you can actually make sure the application is available. So you can have staging slots in the app. So within the same app service, you can have multiple code bases, right? You can have a production environment, and then you are moving your new code into the staging, and then your last code, like the previous version of the application, in another slot. And when you put the new version into production, you can swap it, like an old current version of production comes to staging, and then this is still your old code. But if this doesn't work for any chance, then you can actually switch back and then save your environment. Or if this whole thing is messed up, then you can actually go back to another version, right? Older version or something. So, but this is only talking about application. You should be aware of database problems, like when you are like deploying an application, sometimes people make changes to schema and all that, and you should be aware of how to track back and then all of that. I'm not talking about database here. It's all about applications. And these are some of the patterns for availabilities, but I will quickly have to go through now. And so the health check endpoint is when we are using an application, you don't want an app to be constrained by the non-availability of another service. Like let's say you have a service-oriented architecture, service A and service B are running, service A uses service B. And if service B is down, your application has to be coded in such a way that it should be aware that B is down and not wait endlessly for it. Right? So you should have a health check type of situation. This is pretty much useful in the traffic manager and load balancers and all that will implement it in itself. But if you're writing an application to be using another application, you should have those checks. Like make sure that you should have a condition B, like if this is not available, what am I doing? Things like that. So that's kind of an architecture within your application that you should be aware of. And this is the queue-based load leveling that we talked about, and we have many two systems that are like asynchronously communicating, and this service could be loaded based on the conditions at that time. There may be other applications that are using the service. There may be resource constraints and all that. So if the other task is waiting on this endlessly, then you will have a problem if it does not stand. So you basically push your stuff into a queue, and this will consume it at its own pace, right? So this is another way of leveling your load.
But then the issue is, what if your queue goes down?
Yeah, the queue goes down.
Then you're screwed. Wait, settings.
This going through all these things. Yeah. But the queues are actually, you can even have VR for queues. Yeah. But then that means that, it is not, it may need some manual support.
It won't have as much of a speed if you have to have VR.
Yeah.
That's another pre-active Kafka or something. Well, still, Kafka, you can't scale. Officially, you can. There's like something called Mirror Maker that will move data around, but it's not as good as it should be. It's like master. Still master.
Okay, so I think partly you know that, right? If you don't want to have, so let's say there are two services and you are, if the load on this A to B is going up, then you can actually throttle it sometimes. Like the B is not a critical service, you can say after 10,000 requests you are not going to serve anything more, right? So those kind of things is rate limiting and tiering. Disabling the function, you will say this service is not available now, for example, right? So things like that. And all right, cool. Now we just talked about scalability. Now for availability, we have it's almost the same concept. You have a region A and a region B with a load balancer, which is like a front door, and you have a database replication. It's a pure application. Right now, I think SQL doesn't give multi-master. But so basically, you still use the same database, but your application is possible. When this goes down, then you may have to switch your database into the other database. But this gives you global redundancy.
That was EB that on the master application as your SQL database.
Yeah, Cosmos is right.
Basically, put your queue in Cosmos.
Yeah.
Actually, put everything there. Yeah, I know.
Yeah, so I think you guys are all database guys. I'm not so much.
Except when your application is too old, right?
Was it?
Except when your application is too old.
Yeah, right.
So this is another way. I mean, also can talk about this, right? So this is how you have your application of your database. Like I'm expanding that part of the database in the previous slide. So you can, if this goes down, you can go to the secondary region, and you can have a traffic manager to access this database if you want. That's another pattern. Alright, so you asked about front door, right? There is a difference between front door and the traffic manager. Traffic manager is a DNS level load balancer. It's a global traffic manager. You get a single endpoint. You go there, and the traffic manager will have rules to route your traffic, right? It could be any number of rules such as vicinity, like your how much is the latency, or you can have active, passive, all sorts of things. Like it can route into any place, but it is just a DNS selector, right? I'm just saying that I want to go somewhere, and it decides where to go. And again, once you hit the Azure Traffic Manager, the traffic from Azure Traffic Manager to Azure is still through internet. But front door is actually an edge, it's a point of presence service from Azure. So it will deploy this front door across all regions. And so when you hit the front door, you're already in Azure. And so that way, the front door is a single name space, but then when you hit there, you are already in Azure and you go to the right region. So it's much faster. And it's also a WAF, like a web application firewall. So it gives you, traffic manager is pretty much a DNS. It doesn't have any root or anything attached to it. It's just a selector, right? And it can take any traffic like TCP or anything like that. But front door is pretty much a HTML traffic, right? It's a Web 7 or like Layer 7 load balance. And so you can write rules like, okay, this particular URL then do something, another URL do something, all kinds of things. But traffic manager cannot do all that. It is just forward, right?
You could put traffic manager in front of front door.
Yes, you can.
If you have several different applications.
Yeah, right, yeah.
Or would you need to? Could you do like a proxy, like URL-based proxying in front door? Or let's say if you have one. Okay.
It does that. But the catch here is traffic manager is optimized for HTML. If your traffic is like another protocol, then probably you cannot use that, right?
Use a traffic manager.
Front door is HTML, right? Yeah, traffic manager is TCP. Yeah. So yeah, it's on HTML. Yeah. So I think this is traffic manager, right? You keep this control.com, and traffic manager decides where to go. You can have different rules like latency. The process service round robin, it goes 1, 2, 3, 1, 2, 3 like that. Just keep rotating. Failover, always like it does a health check. If the health check fails, it can fail over to the other region. Or it could be nested. You can write your own rules. You can add up all these if then kind of rules.
Does this front door has the under attack for the cloud fronts? Cloud fronts will have something that you can put under attack mode.
CloudFront is like CDN, right?
CloudFront does have CDN, does have dynamic CDN.
CloudFront is equivalent to Azure CDN, but
it does have WAF as well.
Yeah, but front door is sort of CDN because it is a point of presence service at edges, right? With the load balancing capability, like with the rules engine for routing traffic. But for heavy CDN type work, you have to still use CDN. CDN will have the difference is that CDN will take the static assets from whatever server it is and keep refreshing it based on your time to leave ETL, and so that is the actual. I think CDN comes after this front door. You keep the website, and then you have assets that you wanted to serve as close as possible.
I think the most valuable thing to talk to, as you said, is because it's in the Azure side, it doesn't have propagation layer.
Yeah, right. Yeah. It is. There is a. To boast about it, there is. I have seen a timing diagram where the latency of AWS and front door is almost very fast. Like you see the line at the very bottom of the screen. Actually, it is a very good service. People are using it more and more. And you guys probably know this type of layer. So you have the front door in the front, and then you have load balancers. This is HTTP layers. If it's a traffic manager, it's a DNS. With the front door, it is a layer 7 load balancer. You can have if you are hosting it in a virtual machine, for example, you can have load balancers in front, and then you can also have application gateway. This is but if you are using front door, application gateway is redundant, you don't probably need it. because front door will do lots of things.
Even if you have front door at the top level there, you
Yeah.
can manage the URL structure all the way down.
Yes.
So it would know, for example, if you ended on EMEA, you go to slash whatever, it'll persist that all the way to the VM level.
Right. But you can, if you want within a region, if you want to do some stuff, App Gateway is a region only service. I think we talked about the front door. Cosmos DB, I'm not a specialist on database side, but I just wanted to put this up because when you are doing a global deployment, Cosmos DB is a very good tool for you. It's a globally available database. It has multiple protocols that it will support. You can do the data in different ways, and it actually supports different consistency models. You guys already know this. The strong consistency means like the data is always consistent. Like the reads cannot precede the writes in any fashion. And the relative consistency is like you just try to write it and then you get whatever you can get. So this gives you more availability and higher throughput because you are moving faster and faster. But depending on your application, you have to take one of those consistency levels. Like let's say you have an application running all over the world, and then you know that your users in the US are going and doing certain things, but users in Japan are doing, which may not overlap. Then you can even use eventual consistency or session level consistency. Like the sessions which are in that particular session are consistent. You have to make a choice from the consistency level. Yeah, so this is another. I just want to give an example of an app that we deployed for another customer. They have a application that was globally available, and it's a single page application. They have an on-premise environment, and this is through Microsoft. And basically, this is the inbound user or the app flow. The user actually hits the front door, and then it hits one of the apps, and the data is coming from a Cosmos DB that is globally available across the board. And then we use Azure Cache here for session replication. Right, this is another concept you need to know, because let's say this whole thing goes down, and then you are routing the user from this to here. And let's say he or she is like half done, and then something goes down. And then whatever is entered, the session state has to be preserved and it has to be moved into another server. So that's why we take this and then replicate it into the other mode. And your session is preserved, and then you just continue with the other app. And here we actually use some of the concepts, like these service endpoints. Like I'm locking down this gateway so that nobody else can hit this endpoint. And we do IP restrictions, and we do VNet integration here. This is put in a VNet, and this VNet only can access this app service. And this is and in the outbound flow.
Did app gateway have the domain services or the public services?
There's a bit, I don't know.
App gateway. Gateway app.
Oh, it's an app. It's an app. We call it.
Sits on the public services or sits on
No,
the
it's private.
private?
Yeah.
And do you have an IP attached to it? Or?
It has a private IP attachment. So that's the access restrictions, and here it is the VNet integration. So basically, this VNet to this, basically because of these two are in the same VNet, we can already talk to. Yeah. Now, when you go into the outbound mode, this, basically what happens is this has a database and it's an application that has some things, some events are now happening. We are pushing everything back into the Cosmos DB for this app to use. So basically, the app comes and updates the Cosmos DB, and this comes and then updates the Cosmos DB and does some back and forth. So here it is actually still using some of those concepts that we talked about. Like say, whenever event happens here, it uses the gateway service. It calls the gateway and then pushes into a queue, and the queue calls, and the function app comes from retrieves the queue and then updates, and uses this app to update the database or the Cosmos DB. So this is the traffic going there. So this is a separate application used in on-site where they work with this app and then create some sort of data and all that. I just wanted to show you in a real life example. I don't have a lot of time now, but I think I wanted to cover microservices, but this is the next level. We wanted to make the application available and less maintenance. Basically, in the earlier application, we have more apps, and now we have services, right? So you are shredding the application. Like in the database, also you can do that, and you are actually taking the app and making it an app is a sigma of all these services, right? So basically, each service can be managed at a smaller level, so the outage can be minimized in that sense. And then there is also a pattern that you can actually search for Azure architecture patterns, and you can see all these things. And this is how you, because I'm out of time, I will go through, and I will also show about. Now let's talk about DevOps. With all these things, you also want to make sure that your global app is deployed and maintained quickly. Right? You can do a whole lot of things on your deployment, but then code movement and development has to be fast enough to survive that. So that's why we use DevOps. DevOps actually has multiple elements. You plan and track your work all the way to the release. And then you have a developer task. You just come from here and build based on the plan. And there is this is the DevOps line, more like operations DevOps, and this is more like planning and execution techniques, right? So Azure DevOps is a managed service that gives you all these things. Traditionally, you can actually host all these things in your own environment, but Azure DevOps is a platform service that you can build pipelines and all that, and it is friendly with all sorts of tools like this. Like you can bring your own tools, and then Azure DevOps can support all that, and you can build your pipelines and all that. So, yeah. Now, so you have this is the using Azure DevOps. Actually, you can use Visual Studio to publish into Azure repos, which could be a Git or something under the cover. And then the pipelines, you can define the CI pipelines, integration pipelines, and deployment pipelines, and you can deploy into all that stuff. And then the Azure App Monitoring, App Insights can give you feedback, and then you keep developing all that. So I also have another slide for web apps. You can do the same thing for web apps. So I think that concludes my session today. Thanks for listening. Hopefully it was useful. If you have any questions, please let me know.